Hello friends, Mr. Depsick here. I'm going to try to teach with a mask on. I want to practice it before we get into this. It is our foreseeable future. And I have two goals for today. First off, I'm on page 7 or page 8 of the note packet. I forget which one. My two goals for today are to first teach you what a tautology is, and the second, try to solidify the idea of what a truth table is for, So goal 1 is pretty easy. A tautology is a statement that is true no matter what. It ends up being true regardless of the premises that you start off with. That's it. Now, we use truth tables to help us figure out when we have a tautology, because basically if that last column is all T's, then whatever's in that column is a tautology. Always true no matter what. The second thing I want to try to do is explain how I set up a truth table myself from scratch if I have to, but I want to make this very clear to you guys. I'm never going to ask you to set one up from scratch. Everything you see on the paper right now in black, I would give to you for free. So in the second video, I am going to go through how to fill out this truth table and explain how the result helps me determine if this thing up here is a tautology or not. But I do want to talk briefly in this video about how I got these column headers and these rows over here filled in. You don't need to know that, really. So if you feel like you understand it well enough or you're not that interested, just go on to the next video. I will not be offended. It's okay. Now, for everyone who stuck around, here's the deal. Here's what happens. When we have a complicated statement like this and we want to know something like, is this a tautology? Is it always true? Or is this a logical equivalent of this other more simple statement? Like, can I say it this way instead? Let me look at truth tables for both and see if they match up. The reason why a truth table does do that is because they start with the very simple, most basic statements. Whatever's actually in your crazy-looking statement, you just start with the basic version of those. So as crazy as this is, with all its negations and compound statements and conditional statements, all that stuff, it's just some kind of combination of M and N. And this is all the things that M and N might be. They might both be true, or M could be true and N could be false, or M could be false and N could be true, or they could both be false. There's no other combination that'll work. It is not a coincidence, by the way, that every time I do these, I start off with true, true, false, false, and this goes true, false, true, false. I try to always keep it like that, because then if all my tables are consistent, when I'm comparing a table to decide if there's logical equivalents or tautologies, it's just always the same. Everything else that's in this table is designed to help me ultimately get to what I want to know. This is what I want to know. This is what I'm trying to determine is a tautology or not. But I don't want to have to ever look at more than one column at a time. So I'm basically going to go through, break this statement down first into I'm going to break it down into its smaller components. This statement, before I can figure out if this is true, I've got to know what's going on with this and what's going on with this. But before I can know what's going on with this, I got to know what's going on with this and with this. So as I was creating this table, what I was doing was saying to myself, I want to figure out what happens when this implies this. I got to figure out what happens. I know it's got M's. I know it's got N's. I'm going to do all this stuff here first. Fine, great, perfect, fine. Before I can figure out what this is, I need to know the value of not M and not N. Because if I know the value of not M and not N, it'll be easy for me to then figure out what happens when the statement not M implies N. So I wanted to figure out this, so I broke it down into smaller components, ones that would allow me to look at just one column at a time, so that I can then put those ideas together. Once I had a column that would tell me all possible values of this, I knew I had to figure out what was happening here. Now you might think, Mr. Depsick, why didn't you make a column for not M or N to figure out not M and N? Well, why didn't I? Why didn't I make a new column for not M and a new column for N? Because I already had them, right? I don't need to make a new column for not m, that's right here. I don't need to make a new column for n, that's right here. I can still fill in this entire column by just looking at two other columns I've already created. And once I have this column filled in and this column filled in, I'll be able to just use these two columns to figure out what happens with this, conditional statement. So that's how I would set this up. I just try to break it up into smaller steps so that I'm only looking at one, maybe two columns at a time. And I'm going to try to progress all the way to ultimately what I care about, which in this case is what are all possible values for this really complicated logic statement. So in the next video, we're going to go through how to fill in these values. Feel free to try it on your own before the video starts. I am going to talk through it very thoroughly. So, you could maybe fast forward to the end to see if you got it right, or maybe I'll start with the answer and then I'll talk through it. That's what I'll do. All right, see you guys in a bit.